Hey guys, today I'm going to teach you how to do implicit differentiation. You'll use implicit differentiation anytime you can't easily solve for y. So normally in calculus we're used to equations where y is all by itself, but there are cases where it'll be y is in the equation itself and we can't easily solve for y, so that's where implicit differentiation comes in. So the main idea here is that we are going to take the derivative of both sides of the equation with respect to x, even if the equation has y or y's in it. So, but there is a trick to this. So anytime you take the derivative of y, you will multiply by dy dx because y is a function of x. So let's solve this equation as an example. So we are given y squared plus x squared plus y squared equals 25. And let's start by taking the derivative of both sides. So the derivative of x squared would be, using the power rule, bring our 2 down and subtract 1 from the 2. We get 2x plus, same with the y, we bring down the 2, 2y minus our 1, we get just 2y. And then now we need to multiply by dy dx because y is a function of x. So we're going to multiply by dy dx. Technically, when we are doing derivatives with just y by itself and an equation, we are multiplying by dx dx. So when we do the derivative of this, we do 2x times dx over dx. But since this would just equal 1, we typically just don't write it. So back to our original equation. So now that we've multiplied by our dy dx, we've found the derivative of one side of our equation, and now we find the derivative of 25, and this is just a constant, so it will just be 0. So now we are trying to solve for dy dx, which is the derivative of the function. So dy dx is equal to, and now it's just a matter of moving variables around to isolate dy over dx. So first we're going to subtract over our 2x. So our 2x is gone from our left side. So we have our negative 2x, but we still have our 2y over here. So now that we have our 2x is gone, we need to divide by 2y so we can isolate our dy dx. We're going to divide by 2y on this side as well. And then we are left with negative 2x over 2y, and the 2's will cancel out. And finally, you are left with negative x over y. And that will be the derivative. And that's how you use implicit differentiation when your y is not isolated and it's in your function. So even though we didn't solve for y, we still found the derivative, and you can use this anytime x and y are tangled up in an equation, such as in circles or other curves that don't work with the regular rules. So I hope you guys learn how to do implicit differentiation from this video. Thank you.